All right, let's get into it. We're going to explore the very curious case of a geometric shape that's, well, it's both stunningly complex and, believe it or not, surprisingly simple. I mean, just look at it. At first glance, it seems incredibly intricate, right? It's this beautiful puzzle of flat surfaces and sharp angles that kind of just makes you want to figure it out.
And then there's its name, the Rhombicuboctahedron. Yeah, even the name, which we first see from the amazing astronomer Johannes Kepler, sounds super complicated. It's a bit of a mouthful, for sure.
But here's the twist. What if I told you its whole story actually starts with one of the simplest shapes you can possibly imagine? This is where our little mystery really starts to open up, connecting something that looks super complex to something we all know.
Because, as it turns out, this really complex-looking form has a surprisingly humble beginning. Yeah, it all starts with the basic six-sided shape we've known since we were kids, the good old cube.
So, how do you get from a cube to that? Well, one way to think about it is like you're expanding the cube, kind of like a flower blooming from a bud. Picture this. You grab each of the cube's flat faces and just pull them straight out, away from the center. And as they separate, these new surfaces magically form to perfectly fill in all the gaps.
And that's exactly why it's also called an expanded cube. This image illustrates that relationship perfectly. You can almost see the original cube still sitting right there in the middle, housed inside this new, more elaborate shape. It's like a ghost of what it used to be.
So there are really two ways to think about this, and they're both totally correct. You can see it as building outwards, that's the expansion model we just talked about, or you can picture it as sculpting inwards. Imagine starting with a big, blocky cube and just carving away at the corners and edges to reveal this perfect shape that was hidden inside all along.
And what's really cool is how the math just lines up perfectly. It confirms this connection to the cube. In fact, if the edge of our Rhombicuboctahedron has a certain length, the big cube it came from has an edge length that's exactly 1 plus the square root of 2 times bigger. It's not random at all. It's this perfect, elegant mathematical relationship.
Okay, so what exactly is this thing made of? Let's break down its anatomy, piece by piece.
All right, so if you look at its surface, it's actually a mosaic made of 2 different shapes. First up, it's got 18 perfect squares.
And then, filling in all the gaps, you've got 8 perfect equilateral triangles. And if you think back to that cube, these triangles are sitting right where the corners of the original cube would have been. So, let's add it all up. In total, that gives us 26 faces, 48 edges, and 24 vertices. And you know, these very specific properties put it in a pretty exclusive club. It's what's known as an Archimedean solid, one of only 13 of them actually. They're a special family of highly symmetrical shapes built from more than one kind of regular polygon.
But here's the thing. This shape isn't just something you find in a math textbook. Not at all. Once you know what you're looking for, you start seeing it, well, everywhere. It's had this fascinating secret life, just hiding in plain sight.
I mean, for centuries, this shape has totally captured the human imagination. You can find it in Leonardo da Vinci's famous illustrations for a book way back in 1509. It even shows up as a glass model in a Renaissance painting. And jumping forward a few hundred years, it was the basis for some of those wild Rubik's Cube-style puzzles during the big puzzle craze of the 1980s.
And it's not just small stuff either. It's also been scaled way up to create some truly breathtaking pieces of modern architecture. I mean, look at the National Library in Minsk, Belarus. It's a giant Rhombicuboctahedron, and that unique structure, with all those faces pointing in so many different directions, makes it a perfect connector, or a hub, for building even more complicated designs.
So let's bring this all back home, back to the central idea of what this shape really is. And it's kind of a beautiful paradox when you think about it. It just perfectly embodies this dual nature. Is it simple? Yep. Is it complex? Absolutely. It's this incredibly beautiful, intricate-looking form, but it's born from one of the most simple, fundamental shapes we can all picture, the cube.
And that really leaves you wondering, doesn't it? Where else in our world are these incredibly complex patterns just hiding inside simple beginnings? It makes you think about all the other beautiful geometric secrets that are probably out there, just waiting to be discovered, hiding in plain sight, all around us.